Okay, so let's see if we can get through this in one class period. It'd be nice. It seems like it takes us 2 or 3 periods just to do one lesson lately. So hopefully we can get through this in one class period. So let's talk about what a I'm not going to talk about that. Yeah, let's talk about this. So I'm going to do just a little graph, just a little sketch of a graph, and talk about, oops, I got to change this right here to white. There we go. And let's do another one. So I'm going to copy this so I can paste it to a few things. All right, you're going to see this a couple times today, but here's the first one. So if you had a graph that looked like this, looks like an upside down parabola. So what would your basic function be for something that looks like this? Y equals what?
X squared.
Is it x squared? Negative x squared, because it goes down, okay? So this would be y equals negative. But I'm not worried about that right now. Now, the last thing we did talk about was increasing, decreasing. Remember that? Yes? Friday, we talked about it? Yeah. All right, so where is it increasing? Let's say the top of it's right there, okay? So where is it increasing? From negative infinity to where? Nobody?
To whatever that point.
What is this point? It's the y-axis. 0, right? That's 0 right there, isn't it? Okay. So where is it increasing? From where? From negative infinity, where? To 0. And where is it decreasing? From 0 to infinity, to positive infinity, okay? Or they might say everything, what? Less than 0, right? It's increasing for all x is less than 0, and it's or did I say increasing? I forget what I said now. It's increasing for all x's less than 0, and it's what? Decreasing for all x's what? Greater than 0, okay? But what about the part where it's not increasing or it's not decreasing? Where would that be? It'd be right there, okay? Now, this point is a critical point, and since this is the highest point of that graph, we call this a maximum point. And we've used these words before. We've used maximum and minimum before. Maximum point. Okay, so that is one of our critical points. Extrema just means all these different points that we're going to talk about. It's just a word that kind of sums them all up, okay? So a maximum point would be one of many things that are called extremas, all right? It's plural. There's a plural for maximum. I think it's maxima, all right? I think that's in the book. You can look at it. I don't know if we're going to use that word very often, but that's what it is. So this is a maximum point. Now, there is something that we're going to talk about that's, do you remember in geometry when we had a circle? Remember you had, let's draw this. Remember you had a circle, and then you had points that go through, or a line that goes through the circle, hits at 2 points, but you also had a line that hits at 1 point on the circle. I know it's been a couple years. Does anybody remember what that word is when you have something that hits that circle just at 1 point? Starts with a T. Anybody remember? Say it. Who said that? Alua? Okay, tangent. Hannah, I thought that was you. That's why I looked at you. All right, so this is a tangent to the circle. Is that coming back to you at all? For those who had me in geometry, we talked about this a lot, didn't we? Yeah. So that's a tangent to the circle. What we're going to do is we're going to draw a tangent to this curve. It's not a circle. It is a curve. We're going to draw a tangent at that point, at that maximum point. So it would look something like that. Now, we're not going to talk a whole lot today about that tangent, but this is something that has a lot to do with calculus. All right? When you draw a tangent to a point, we consider that to be the derivative of that equation, or that function, I should say. The derivative, that's a very calculus word, okay? You're going to spend a lot of times talking about derivatives. All right, so the slope at this point is considered to be the derivative of that function. All right, don't worry about it right now. I'm just throwing a couple words out at you that you're going to see later on when you take calculus and you're like, oh yeah, I think I remember him saying that word, okay? So, but that right there, if it's, yeah, so that would be a critical point. So, yeah, we'll just end that right there. Let's do another one. There's actually two maximum points we're going to talk about. We're going to talk about a absolute maximum, an absolute, which this one would be, okay? And then we're going to talk about, what was that other word? A relative. Now, if you look on YouTube, a lot of times, I've watched a couple YouTube videos where they did use the word absolute and relative, but then other ones used local. I'll put this in parentheses. They used local and global. So just in case, if you were like doing a search for this stuff for critical points, and the person on there is talking about a global maximum and a local maximum, it means the same thing as absolute and relative. Okay, but this book chooses to use the word absolute and chooses to use the word relative. So that's what we use since this book uses it. But just so that you understand, those are two other words that you could use as well. It means the same exact thing, right? Well, what's the difference between an absolute and a relative? We'll talk about that in just a couple minutes, all right? Let's do a couple more things, then we'll get back to this. Remind me to get back to this, all right? It's in my notes, so I should remember, but let's do another one. So let's do another one. And, oops, not what I wanted to do. Let's click off of this. There we go. Now I'll make it red. All right, what if we had something like this? Okay, so what's the function here? It's kind of not really, oops. Excuse me. Let's move about right there. That looks a little bit better. So what would I call that function? Let's say that it crosses here at 1, y equals 1. What do you think the function would be? What do you think the equation of this graph would be? Well, first of all, it's x squared, isn't it? Because it goes up, but it's shifted up 1. So what would you call this? Y equals x squared plus 1. Yeah. All right, that's not really part of this. It's just to get you thinking a little bit. So does this have a maximum? Does it have a point? Does it have one single point that's above everything else? It's actually got a couple points, doesn't it? Because this keeps on going up here, keeps on going up here. But is there a maximum? Is there a point where it's as high as it's ever going to get? No, because what does that arrow indicate? That it just keeps on getting higher and higher, right? So you can never have a maximum where the arrows are. Does that make sense? All right, just one particular maximum. So what do you think you have on this one? Not a maximum, but a minimum. Good. Pretty simple. Would you agree? So right there. So that would be your minimum. All right. And let's just do the increasing, decreasing thing. So from negative infinity to 0, what's this graph doing? Is it increasing or decreasing? From negative infinity all the way to here, what's this graph doing? It's decreasing, right? It's getting lower and lower, isn't it? The function's getting lower. The f of x is getting lower and lower. Okay, so as x increases, is that how we said it? Or anything less than x, right? If I said x is less than 0, what is this graph doing? Is decreasing. What about if x is greater than 0? What is this graph doing? Say it. What's the function doing? What's the f of x doing? What's the graph doing as x gets bigger and bigger and bigger? It's increasing, right? So it's decreasing here, and it's increasing there. Make sense? It's just a little review, just to make sure we remember about the increasing, decreasing thing. All right? So this is our minimum point right here. And again, if I put a tangent to this, this indicates the derivative, and I'm not going to worry too much. I don't think on this lesson anyway, we're going to worry too much about that horizontal line, or that tangent line. But it is tangent. It's something that if you watch videos, they talk about it all the time. So I wanted to make sure that I put that in there. So I don't think we're going to worry too much about the tangent right there. I think I don't even want to say that because I'm not sure. All right, let's do another one. I think that's all you need to know about that for right now anyway. Again, we're going to talk about that absolute and what was the other word? Relative minimum, but not right now. We are going to talk about it in just a minute or so. Let's put another one on here, and I'm going to show you another graph. So we did an x squared, right, where they both went up, they both went down. Now this one, I'm going to do an odd one with an odd exponent. And let's take a look at that. And let's see if there's a minimum and maximum with that. So this is going to be an x cubed, so it looks like that, and it looks like that. So is there one point that it's the lowest point, the minimum? Is there one point that's the highest point, the maximum? There's not, is there? All right? Because if I keep going down here, I'll never get to the lowest point. If I go up here, I'll never get to the highest point. What about this point in the middle? Well, that's neither a maximum or a minimum, is it? All right, so I can't say that. But this point does have a something that's true about it. And you know what? I should have done this. Let's do this. I'm just gonna move this over a little bit and up a little bit, so it would go this way and this way. All right, there it is. Now, where does it, let's say this is at, I don't know, 3, all right? Where on the x-axis is this thing increasing? From where to where is it increasing? From, again, on the x-axis, from negative infinity to where? Look at this graph. As it moves to the right, to the right, to the right, what's it doing? As x goes to the right, what happens to this graph? It's increasing. Up to where? That point right there, okay? But does that mean that that's a minimum? Does it mean it's a maximum? No, but it is a critical point, though, all right? So we've done 2 critical points so far, minimum and maximum. This is a critical point, but it's neither one of those, all right? Now, from, let's say, 3 to infinity, what's it doing? It's increasing as well. So where is this thing increasing? From negative infinity where? All the way to positive infinity. This thing is always increasing, right? So from left to right, because this will keep going this way, this way, this way. So from left to right, this thing is always increasing, all right? Let me, I didn't write that down. Should have written down an explanation. That's all right, you won't mind. Anyway, probably. Let's take a look at this. Remember we did the tangent to this? This really doesn't have a tangent, but at this point right here, it does have a slope. See, that's kind of like your dividing line. You see it? It comes up like this. Here's another thing you might see, and I don't know if they do this in this lesson, but watch. This graph, it doesn't do this, but if I got rid of this part right here, this upper part, it kind of looks like it would go down like that. I mean, that's not really part of my function, but it kind of looks like it would do that, doesn't it? This goes up and it comes down like this. Okay, we call this, I think they call it opening concave. When it opens down like this, see how everything is down, right, up to this point? And then everything is what here? It opens what? It opens up, or it opens, I believe they call it convex. Don't quote me on that. But anyway, you'll see that from time to time. I don't believe they talk about that in the book. They might. I just might have missed it. I didn't write it down. I know that. So do you see that dividing line where it opens down and it opens up? We have a name for that right there. So that line right there, it's a vertical line, and it goes through this point. By the way, it's a vertical line. So what's the slope of this line? Oh, I know I did it. What's the slope of a vertical line? Say it. It's undefined. That's right. So the slope of this line, so the slope is undefined. Now I think I remember what I was going to talk about as far as the slope on the other ones. So if you can have, again, I'm pretty sure this is new to me. I'm learning this very, new as well. This is stuff that I really never, at least if I was taught it, I don't ever remember being taught this. So this is kind of new for me too, because I'm just learning it. But if you have a slope what's the slope of this line right here? It's 0. So if you can have a slope to a critical point and it's either 0 or undefined, or I should say, if you have a slope of a point that's either 0 or undefined, then that point is going to be a critical point. So for instance, I have a point right there. What is the tangent to that point? It looks like that, doesn't it? Okay, would you agree? Just hits at one place. Is that slope 0 or is it undefined? No, it's not. So this is not a critical point. You with me? Because look, I could have a million of those, literally way over a million, an infinite number of points where, oops, not what I wanted. Watch, I can have an infinite number of points that the slope is not 0 or undefined. Whoops, I didn't draw that very well. Let's see if I can, it's close enough. You see that? That's tangent to it. But is that a 0 slope or is it a vertical slope? No, it's not. So those are not what? Critical points. Okay, where are my critical points? Where I could, if I was to draw a line tangent to it, if the slope was either 0 or if the slope was undefined, then that's one of my critical points. So don't choose a critical point unless you can take the tangent or the slope of the tangent to it. The slope of the tangent would be either 0 or undefined. So anytime this is undefined or it's 0, then that is a critical point. So this point right here, let's go back to this. This point right here is a critical point because if I draw a line vertical to it, it splits this into 2, and so that's a critical point. We call that a point of inflection. Point of inflection. Okay? So a point of inflection has a slope, it's a vertical line, and the slope is undefined, so this is still a critical point. So we got 3 critical points. We got a maximum, minimum, and a point of inflection. All right, and I think that's all the critical points that we have, but we're going to get a little bit more detailed about those maximum and minimums. So now is where we're going to do it. So let's do this again. And let's draw this, let's make this a little bit bigger. Okay. And let's draw a graph. Now I'm just going to draw some weird looking graph. So let's say it starts right here. And I don't know exactly what the equation of this graph is. I just want to look at the critical points. So it goes up like this. Oops, let's try it again. Let's see if I can do it all at once. And it goes up like that. All right, so there's a graph. Crazy looking function. But what I want to look at is I want to look at the critical points. All right. So if you look at this, do you see this point right here? This is going to be my lowest point. It comes down and then it comes back up again. So this is like the bottom of this curve and it's the bottom of this curve. So what do you think we're going to call this one? Which critical point? You got 3 to choose from. You got maximum, minimum, or point of inflection. This is a minimum, okay? Hold up. Let me look at my book for a second. I think I might have rewritten this wrong. Let me see something. 3/6. Don't lose me. Just wait until I figure out what we're doing. 3/6. And then the beginning. Oh, yeah, I did. I just wrote it wrong. It's right in the book. I'm glad at least I noticed. Let me change it on my notes. Because I looked at that. I'm like, there's no way. Because I wrote that point was a absolute maximum. But there's no way that's a maximum, is there? What is it? It's the lowest, so it's a what? So it's a minimum. And I wrote it right here too. Stupid me. All right. Glad I caught it. Because if I wrote maximum right there, you guys would probably be flipping out, wouldn't you? All right, so this right here is a minimum. And I'll show you why it's an absolute minimum. All right, because that's as low as that graph can go. Would you agree? This particular graph right there, it's not getting any lower than that. All right, it's not coming up and then going way down here or anything. This just keeps going that way. This keeps going that way. This right here is an absolute minimum.
If you're a part of the prom committee, you're meeting after school in room 206 today. If you're part of the prom committee, you're going to meet in room 206 after school today. Thank you.
We'll make that yellow, okay? But I see a couple other critical points. Do you see how this thing goes up? It's kind of like a little hill, right? And it goes up to the top right here. It's got like a little peak to it before it starts coming back down. If I drew a line that's tangent to that point, what kind of a line would that be? Be a horizontal line, which means this is a what? It's a critical point. Anybody playing along? All right, I'll just do the talking, I guess. All right, so this is a critical point. Now, is this a maximum? Is it a minimum? What is this? Point of inflection? Now, because both of these are going down. You see that? So it goes up and then it starts coming down again. This is kind of like the top of that hill, okay? Top of the hump, okay? The hill. What do we call it when it's at the top? It's a maximum. But the problem is, you got other points that go higher than that, don't you? So we don't call it a absolute maximum. What do you think? What is it? What's the other one? I had absolute and look in your notes. I wrote it down. Relative. So we call this one a relative maximum. I'll just put max. Is that all right? This is a relative maximum. They go through this thing where they say if you take points, from here to here, this is higher than any points that are closer to it, okay? So it's just part of a little region, but that little hill right there, that's the top of that little hill. Is it the top of the whole entire mountain? No, because the mountain just keeps on going and going and going forever. That would be absolute. Now, do you see something else? I didn't draw it super nice, but this kind of comes down to a bottom of a hill right here. Do you see that? So this right here would be called, this is also a minimum, but is it the absolute minimum? No, because this is the absolute minimum because that's below this. But this is part, right? Pretend this is like a nice curve like that, okay? This is at the bottom of this little hill right here. So what do you think we're going to call that one? It's a relative, what? Is it a maximum? It's a relative minimum, okay? So that would be that point right there. It's still a critical point because if I drew a tangent to that point, I get a horizontal line. Now look at this. Let's do this in a different color. Let's go blue. Look at this. This kind of comes down like this, and then it kind of comes up like that. You see that? It starts going down, and about right in here somewhere, it starts changing direction. Do you see it? It kind of comes over. See how this goes down, and this part, it opens up. Remember that? So what do you think I'm going to call this point right here? That's the point of inflection, okay? So point of inflection. So all we're trying to do is just recognize where these points are on the graph. That's what they want you to do. And this is very, very helpful in calculus. This is why this is pre-calculus. Okay, we're preparing you, right, for calculus. So we're not really going to do any real calculus in here, but this is a good preparation for calculus because they're going to talk about these things, okay? And that's pretty important stuff. All right, let's keep going. Let's do another one. They don't have to be nice, pretty curves like we've been doing. Well, some of them weren't so pretty, but they don't have to be curves. They could be like this. Oops, I thought I was in a different color. Let's go red. There we go. And so what if you had something like this? And you got arrows down the bottom here. All right. Now, on this one, you can't really take the tangent to that, but it's still the very top of this graph, isn't it? So what do you think we're going to call the top of this graph? What do you think we're going to call this point right here? Yeah, it's still the absolute maximum because it's the highest point of this graph. Even though the graph's going down, this is the highest point of that graph. So we call this the absolute maximum. Again, I'll just put max. All right? So sometimes they look like that. Right, let's do, we talked about that. All right, now let's do an example. This is an actual example. Again, I'm just going to draw a rough sketch of this graph, and I'll put the points where it crosses so you can kind of know. It may not be the prettiest graph in the world, but it should work. So what if I had a point at -3, -1, and I'm going to put a point right there. Then I got another point at, oops, that's all right. I'll keep it white, doesn't matter. 1, 5, 1, 2, 3, 4, 5. Put a point right there. And then I put 4, -4. So 1, 2, 3, 4, 1, 2, 3, 4. 4, -4 is about right there. All right, and then this is really not much different than what we've done before, except it's actually got some numbers on there. So I'm going to try to draw this in one shot. Come on. Oh, that was kind of ugly at the end. I was doing pretty good. Got a little squiggly in there, but that's terrible. This should be a nice smooth curve that goes up like this. I'm not going to try to redraw it though. Everybody okay with that? All right. And so where is that point? That's at 4, -4. Where is this point up top here? That's at 1, what? 5, right? 1, 2, 3, 4, 5. And then this point right here is at what? -3, -1? Okay. So here's what they're going to ask you. They say locate the extrema. What does that mean? What do I mean by extrema? It's just my what? My critical points, okay? It's the minimum, maximum stuff, okay? So it says locate the extrema for this particular graph. It says name it and classify the extrema of the function. Name it, which means tell me what point. I already put the points in there, so that should be pretty easy, okay? Pretty self-explanatory where the points are. If you were to graph it on your own, or if you were to graph it on Desmos, then you can, we're going to do it in a minute here, you can find that point where it comes down to the bottom, okay? The graph gives that to you. It's an important point. It's critical, right? It's a critical point. So they'll give this to you if you have to graph it yourself on Desmos, all right? So I want to classify it. So what are my points? Well, my points are -3, 1. What do I classify that extrema as? Remember, it's either maximum, minimum. It could be relative or, I forget these words off the top of my head. What was the other word? What is it? No. Relative, and what was the other one? Not relative, but what was the other word? Absolute. Just forget these words. For some reason, I've been watching so many videos on this. Almost all of them talk about global and local, and I'm trying to keep intact which one this book calls it. All right. So what do you think that -3, 1? What would we call that point right there? This is a critical point. Okay, so what would we call that point? It's a what? It's down the bottom of this trough, right? The bottom of the hill, so it's a minimum. All right, but what kind of minimum? It's a relative minimum. Relative minimum. Let me see something. I think there's another thing. Oh, okay, I see. I remember that one. All right, so -3, -1 would be a relative minimum. Why is it relative? Why is it not absolute? Yeah, because this bottom one right here would be absolute, wouldn't it? Because it's below this one, so this would be absolute. Let's go back up to here, though, the 1, 5. So 1, 5. What would that be? It's a maximum. Why is it relative and not absolute? Yeah, because these keep on going up. That means there's points higher than this one. So this is not the very highest point of that graph. Okay, but in this little hill, this little hump, whatever you want to call it, that little curve right there, that is the highest point of that little curve. Okay, that's why we call it what? Relative. Maximum. That would be a max. And what about that 4, -4? Yeah, I would call this an absolute. Even though if you look in the book, you're going to see it written twice. I had a real problem with this. That's part of the reason I had to go talk to Mr. Rao about it. And he's like, yeah, he says, this is definitely an absolute, minimum. All right, if you look at the book, I'm not going to show you what page or anything, but if you look in the book, there's two things that it says. It says something about this is a minimum. It's a relative minimum. But then later on, it says it appears to be a relative or an absolute minimum. And I had a real problem with that. I started watching a bunch of videos, and I was reading about it. And I finally asked Mr. Rao about it, and he's like, yeah, this is definitely an absolute minimum. Just like I thought it was going to be, but they kind of threw us for a loop in the book, which kind of bothered me a little bit. All right, we got a couple minutes, and so I'm almost ready to finish this up. Let me change this so I can see Desmos on the... Okay, so now let's go to this. We'll go to Desmos. I just want to double check, make sure. Yep, it's showing it. All right, so let's graph this. And what we're going to do is we're going to take a function and we're going to graph it. Now, it's going to be very difficult to graph it by hand. So I'm going to have you do it on your computer or on your phone. Okay, using Desmos. So here it is. It's y equals 5x cubed. Now, to do x cubed, I think you can put I don't know. I think there's a way on the keyboard to do it, but I don't know. I just feel like this is an easier way to do it. So I'll put a to the b, x cubed, and then minus 10x squared. And if you want to get your phones out right now and try this yourself, that's perfectly fine. I got no problem as long as that's what you're doing. And then plus 7. All right, so there's the graph. It's a crazy looking graph, but all we want to do is find the critical point. So the question says, determine and classify its extrema. You remember that word extrema? What does that mean? It just means find the critical points, the maximum, minimum, okay, and that's all you got to do, okay, and whether it's absolute or relative. Whew. Hard time finding those words. So here we go. So if you look at this, now this keeps on going and going and going. Like if I made this smaller, you see that? It just keeps on going. Is it ever going to turn back up again? No, it sure doesn't look like it. So we can assume that it's just going to keep on going forever and ever. So where are our critical points? Well, at the top of this hill, this little hump right here, this, whatever you want to call it, okay? At the top of that should be a maximum, right? Is it a relative or a absolute maximum? It's going to be relative, right? Because you do have points that are higher than this point on the graph, correct? But in that little portion, in that little curve right there, that's the highest point in that little curve. So if you click on the graph, see it makes that little gray, can you see that up there? Yeah, it makes that little gray dot. If I click on that little gray dot, it tells me what that point is, all right? I think I can write on this. Yeah, I'm not going to try to write on that, but so it's negative point, we'll just do 2 decimal places. So what would it be? Negative what? 0.67, and it goes up to 14.4. We'll just round it to 14.4. So what is this? This is a relative what? Maximum at what point?
Negative 0.6.
Negative 0.67. We'll just round it 2 places. Negative 0.67, and then positive 14.4. Okay, that's where it is. That's where it's located. Does that make sense? Super easy. Would you agree? All right, you just have to know, is it a maximum, is it a minimum, and all that kind of stuff. All right, let's zoom out a little bit. Let's find the other point. It goes way down here, like this. Then you zoom in. Zoom in. There we go. All right, click on the graph again. Right there. It gives you that little point. Seeing that nice? You click on it, and look where that point is. It's -2, -33. But what do we call that? What do we label it as? Or what do we name it as? Is it an absolute or relative? Okay, now it's down the bottom of this hill, right? So or this trough, or whatever you want to call it. So you know it's a minimum, but it's a relative minimum because this thing keeps on going down, okay? And notice, if you have an x cubed, which this does, one end's going to go up, the other one's going to go down. So are you ever going to have a absolute maximum or minimum with one of the humps there? No, you're not. But what if it was an even power? Then both ends, what does the end behavior do? Both ends go up. So is it possible to have what's the other one besides relative? Absolute, okay? Absolute minimum. Can you have an absolute minimum? Sure. What if it was an even but it was negative? Then your end behavior is going to go down, okay? Is it possible to have an absolute maximum? Yes, it is. Okay? You with me on that? So that's the kind of stuff that you're looking at. And they're going to say use a graphing calculator. I'm not going to require everybody in here to have a graphing calculator. I've tried that in the past. It's too difficult. Not everybody can get one, and it's really tough. But now, with this, you got your phone. I have no problem with you using this as long as, again, on a quiz or a test, you're only using Desmos, okay? And then you're looking for those points, and you just look at it. So that wasn't too hard, was it? Trying to figure out maximum, minimum, relative, absolute, okay, point of inflection. We'll talk more about point of inflection, I think, sometime later. Yep, so that's pretty much it. Hold on. Before you go, listen, this is important. Listen, on your homework, what did I give you on your homework? 13 to 25. Everybody's listening to me? Okay, I don't give it to you until tomorrow, so don't worry about it. So up to 25, everything we did today, you should be good, okay?